Hello everyone, the problem that we're looking at today is the USACO 2021 January Contest Gold Problem 3 of Dance Moves. And before I start with this problem, you need to know that it is required to watch my previous video on the silver version of this problem in order to understand this one in the gold division. So if you haven't already, please go watch that video first, and then now you can take a look at this problem statement yourself first. Alright, so basically it's the exact same problem as silver, however there is one additional constraint of m minutes. So now instead of infinite many minutes, basically like however many spots, you're trying to find, in silver version, you're trying to find the number of spots that a cow will ever occupy, and now it's the number of spots that a cow will occupy in m minutes. However, notice that the silver constraint is also the constraint for the second subtask. So if you just write a silver program, you can still get quite a lot of credits, like half for this problem. But the method I'm going to be explaining here today is how to get full credit for this problem. So you can pause the video first and try this yourself. Alright, first of all the techniques that we used in silver still applies to this gold version problem, as we still discover that we connect edges and there's going to be a bunch of loops, and then we still discover that points on loop all share the points that they ever visit. However, not all points on a loop this time. So I'm going to pull up a drawing here. So first of all, recall in the silver version, say we have first a red loop right here. All right, we're going to have several loops like that. Maybe that's a red loop, and then we maybe have a blue loop that's a completely different disjoint one, and maybe a green loop of just by itself. All right, and now we notice that in the silver version, every single point on the same loop, let me change the color here, every single point on the same loop is going to share the spot that they ever visit, meaning these 4 points marked with purple here, are going to share all the spots that they ever visit because they're going to be in each other's spot after some shifts. However, this is not the case anymore for this gold division version, because we realize that maybe this point might not be able to even get to over here before the m minute pass. Maybe after m minutes, it's only maybe over here, like halfway through. Well, then how are we supposed to find the number of points on this cow is going to be able to experience with a limit of m now? Well, let's just take a look at a singular loop now. Let's ignore every other loop and just take a look at this red loop right now, and let's just mark all 4 of the cows on the loop. And we realize that with m minutes, the number of spots this cow is able to visit can actually be described with a sliding window. A sliding window specifically with a size of m. And for each cow, like this is the window for this cow, and now the window for the second cow is going to be right here with also range m, and the third cow right here with also m. And what about this cow? Well, for this cow, we replicate this first node again back to over here, and we create a same sliding window with range m. Well, what does this mean? So we'll basically, except other than just these cows obviously on the loop, we're also going to add spots that these cows visit in just one switch, one turn of k minutes, right? So let me mark them with yellow points. So this cow visits 3 in its turn. This cow visits, say, like only 2. This cow visits 4. This cow visits only 1. And this cow obviously is a replication of the first one, so also visit 3 points. And we realize that with a sliding window, we actually are able to quickly find all the points that a cow is able to visit within n minutes, right? For this one, it's just going to be this point, obviously, and all 3 points he visit, and then this cow and all 2 points he visit. And for this cow, it's going to be this point and this point. And for this cow, he's able to visit everything he visit in one cycle, and also 2 out of the 3 points that the first cow visits, right? So now we need to find some kind of a data structure or algorithm to help us find the number of nodes in this sliding window. Well, the first thing we do is obviously duplicate this chain twice, and to make, because obviously originally it's a loop, and if we just duplicate this chain and then add the second one on behind the first one, we'll have a chain instead of a loop, which is way better, way easier to process, as I just did over here. Except right now I only duplicated 1 point, but when we actually implement, we're going to be duplicating all of these points and then adding it to the end of the chain. And how exactly to implement this? Well, here's what I did. So basically, I used a map to store, I'm pretty sure I used a map. Oh wait, maybe I didn't. Oh, I just used a bucket, literally a bucket, to store how many times a point occurred, and then every extra time it occurs, we add number of occurrence. And if the occurrence is just reaching 1, then the number of points this cow visited is added, because obviously this is the first time that we're able to reach this point. Otherwise, we don't add the number of points that this cow is willing to visit, because visiting a same spot twice is still only count as 1. And then obviously when we slide the window forward, we have to erase what the previous cow experienced, that this cow does not get to experience because a limited time of only m. So then we have to do buck minus minus. And if buck is already 1, we know after this minusing, there's going to be 1 less spot that this cow can visit. So sum also decreased by 1. And there is one more detail that we need to pay attention to, though, because right now we're adding everything in the set OT, which is the number of points that this cow can reach in just one turn. O for 1 and then T for turn. Quite obvious. And this is not actually everything that this cow can experience, because there's also a remainder, right? Because there could be a remainder when m is divided by k, meaning if m divided by k is not a whole number, then there could be some spots that is not all of OT. Like maybe, for example, this cow would be a great example, because we're not visiting every single spot in cow 1's OT, right? Because that'll be all 3 of those. But we are, however, experiencing all of the spots in this cow's REM remainder. So we use a different set remainder to store the spots that this cow will visit in the time of m mod k. And we also add that to the contribution of this cow. And we use the exact same method, and don't forget to erase the contribution after we're done with this cow. And the whole implementation of this sliding window is quite long, as we are erasing and adding constantly a lot of stuff. So I'm pretty sure that's like 8 for loops that you need to write, but all of them are almost identical, so you can just copy and paste. And other than the sliding window, everything else is almost the exact same as the silver one, so you can just copy and paste from the silver code to this one. And after that, this problem is quite simple. And I would say this whole contest actually is really good. The first one, utter but not hurt, is a really, really good state compression DP problem. The second one, telephone, is a pretty clever implementation of either Dijkstra or layer graph shortest path. And I'm pretty sure I did problem review over both of those already. So now we're completely done with the 2021 January contest goal. Yay. All right. And hopefully after this video, you'll understand how to solve this dance move problem, and not only silver but also gold version of this. Okay, thank you for watching. Grind report today was alright. Not good, but not too bad. But that's for a regular day. Today is Saturday, so I'm supposed to be grinding a lot more, but I did not. Today I mocked the 2018 U.S. Open contest, the gold division of that. I already mocked the silver a while ago, and the silver is actually quite hard, so I thought the gold would be even harder, obviously. But it actually isn't. I feel like the gold is the same difficulty as silver, if not even easier. Out of sort is a pretty good observation problem. I solved it, forgot to submit it on here yet, and the milking order is just way too easy. It's just topological sorting, and I solved it really quickly. 30 minutes, I think. And the talent show, okay, this is a strange one. I have submitted this problem, I think 2 hours ago, and it's still waiting for available grading server. And this is scary. Like, what if this happens during USACO? What if, like, one small bug, I submit it and it runs for 4 hours, and after the contest ends, it tell me that there's one small bug, and I don't get any credit. That's gonna be horrifying, absolutely horrifying. So I really hope USACO is able to fix its grading server in 6 days. And yeah, so this problem is the talent show. It's a pretty good problem on DP, and I don't know if that's an actual algorithm, but I think the people on Logu called it fraction programming. I don't know. Fraction okay, it's something about fractions. Anyways, it's just a pretty new technique to me, and you have to combine that with binary knapsack. And yeah, that is it for the grind report today. I just mocked this contest. It was not too good, not too bad. 2018, so I expected myself to solve a bit more, but it's also U.S. Open, and I did solve the second one, so you know what, good enough. Oh, and also forgot to mention one thing: the talent show. Even though I could not solve it, I did figure out a really, really close DP algorithm, and it did pass every single test case on USACO, which means it's technically right on USACO. However, there is a correctness problem that got hacked on Logu, and it did not pass on Logu, so I had to actually implement the correct algorithm the one with the binary knapsack and fractional designing or something like that. But I'm just saying USACO's data is kind of weak on this problem. Like my program was like the correctness is not guaranteed and it's still passed. Anyways, that's a ground report for today, and thank you for watching. See you tomorrow.